We are continuing with exercise 4A of ITF. Okay, and let's go to question number 8, sub question 1. Solve the following for x in terms of y. So given is y is equal to 2 sine inverse 3x. So we have to write x in terms of y. So x should be on the left hand side and all the other terms should be on the right hand side. So step number 1 will be division of 2 sine inverse 3x. Okay, shift sign on the other side, so this will become sine y by 2, which is equal to 3x. Okay, and then shift this 3 on the other side, so this will be 1 upon 3 y sine y by 2 is equal to x. Okay, therefore x is equal to 1 upon 3 sine y by 2. So this is x in terms of y. Okay, second problem you can obviously try it on your own. Second sub question, and I'll take you to the third sub question. Okay, y is equal to half tan inverse x plus y. First step is cross multiplication of 2 over here. Tan inverse x plus y. So tan 2y is equal to x plus y. Shift pi on the other side. So it will be tan 2y minus pi, which is equal to x. Therefore, x is equal to tan 2y minus pi. Okay, so that was your 8 sub question 3. Let us go to question number 9. Now in question number 9, what we will do is we will discuss the problems rather than solving. Okay. First, the LHS is cos inverse of 4 by 5. And the RHS is, I'll give the hints rather than solving. Tan inverse of 3 by 4. So what you can do is you can convert this to tan inverse, okay, using triangle method. Fine. I hope everybody knows how to use the triangle method now. Okay. Second problem. Second sub question. LHS is tan inverse 2 minus tan inverse 1. Okay. And RHS is tan inverse of 1 by 3. Now we have a direct formula, tan inverse x minus tan inverse y. So that is equal to tan inverse of x minus y upon 1 plus xy. So this formula you can apply where x is 2 and y is 1, and definitely you can get your RHS. Okay, let's go to the third problem. LHS is equal to 2 tan inverse 1 by 3. So this is 2 tan inverse x where x is 1 by 3. Okay, where x is 1 by 3. Fine. Just a second. Yeah. So 2 tan inverse x. Right hand side, I'll just write it for your reference. Right hand side is equal to tan inverse of 3 by 4. So right hand side is tan inverse. So we can convert 2 tan inverse to tan inverse. So this is tan inverse of 2x upon 1 minus x square. We have this formula. 2 tan inverse x is tan inverse of 2x upon 1 minus x square. So this is equal to tan inverse of 2 into 1 by 3, 1 minus 1 by 3 the whole square. Okay. So if you solve this further, this will give you tan inverse of 2 by 3 upon 9 minus 1, that is 8 upon 9. Okay. So this will be 2 ones are 2 fours are, and this will be 3 ones are 3 threes are. Now denominator will become numerator. Send that 3 in the numerator, tan inverse of 3 by 4. Tan inverse of 3 by 4. Okay, which is equal to RHS. That was question number 3. Let us go to question number 4. LHS is equal to 2 tan inverse of 1 by 3 plus tan inverse of 1 by 7, and RHS is pi by 4. So the RHS part is pi by 4. Step number 1, convert this 2 tan inverse into tan inverse. Okay, so 2 tan inverse x formula you have to apply. Okay, so tan inverse of 2x 1 minus x square, tan inverse of 1 by 7. Okay, here x is nothing but 1 by 3. 2 into 1 by 3, 1 minus 1 by 3 the whole square, plus tan inverse of 1 by 7. Now further I won't solve this, but then I'll just give you the hint which is required. Okay, now what you're supposed to do is you're supposed to solve this part entirely, and then this will be x and this will be y. Then apply tan inverse x plus tan inverse y formula. Okay, yeah. So let us go to question number 5. Question number 5, I'll just modify the proof to prove 9 pi by 8 minus 9 by 4 sine inverse 1 by 3 is equal to 9 by 4 sine inverse 2 root 2 by 3. So I'll take this term on the left hand side. 9 pi by 8 is equal to 9 by 4 sine inverse 2 root 2 by 3 plus 9 by 4. Okay, 9 by 4 sine inverse 1 by 3. Okay, so this is the new problem statement. We'll prove this. Okay, so this is the RHS. We'll start from here. So RHS is equal to 9 by 4 sine inverse 2 root 2 by 3 plus 9 by 4 sine inverse of 1 by 3. Okay, take 9 by 4 common. Sine inverse of 2 root 2 by 3 plus sine inverse of 1 by 3. So this is x and this is y. So 9 by 4 sine inverse x plus sine inverse y, that is sine inverse of x root 1 minus y square plus y root 1 minus x square. 9 by 4 sine inverse of 2 root 2 by 3 1 minus 1 by 3 the whole square plus 1 by 3 minus 2 root 2 by 3 the whole square. Okay, now this value within the root, it's 8 upon 9, and this value within the root, it is 1 minus 2 root 2 the whole square. What is 2 root 2 the whole square? That is 4 into 2, 8 upon 9. So this is 1 by 9. Okay, so the first root value is 8 by 9 within the root, and the second root value is 1 by 9 within the root. Okay, so 9 by 4 sine inverse 2 root 2 by 3, 8 by 9 plus 1 by 3 root 1 by 9. Okay, so 9 by 4 sine inverse 2 root 2, and 8 is also 2 root 2, 3 into 3. Okay, plus 1 by 3 into 1 by 3. So 9 by 4, sine inverse of 2 root 2 into 2 root 2, that is 4 to the 8, 8 upon 9 plus 1 upon 9. So 9 by 4, sine inverse of 9 by 9, 9 by 4, sine inverse of 1. Now sine inverse of 1 is the standard value for sine inverse. So sine inverse 1 is 90 degrees. 90 is nothing but pi by 2. Okay. Convert degree to radians, 90 into pi by 180. 90 is nothing but pi by 2. So this is equal to 9 pi by 8, which is equal to the new LHS. We had modified the proof statement, right? So we got our LHS over there. Fine. Let us proceed with the next problem. Question number 6. 9 sub question 6. Okay. LHS sine inverse 4 by 5 and 2 tan inverse of 1 by 3. Okay. What I will do is I'll keep the sine inverse of 4 by 5 as it is. And I'll apply 2 tan inverse x formula over here where x is 1 by 3. But then this time 2 tan inverse x formula, when I apply, I'll convert this to sine inverse because the first term is also sine inverse. Fine. So this is equal to sine inverse of 2x upon 1 plus x square, where the value of x is 1 by 3. So put the value of x as 1 by 3. Okay. Solve this and take the first value as x and the second value as y, and then apply sine inverse x plus sine inverse y formula. We'll get the required RHS. Okay. Let us go to question number 7. LHS is equal to cos inverse 4 by 5, cot inverse 5 by 3. So convert cos inverse into tan inverse using triangle method. Okay. And cot inverse 5 by 3 is tan inverse of 3 by 5. The reciprocal of cot inverse is tan inverse, and the reciprocate the value also 3 by 5. Now use tan inverse x plus tan inverse y formula, you'll get your required RHS. Okay. Question number 8. LHS is equal to tan inverse of 1 by 4 plus tan inverse of 2 by 9. Okay. So tan inverse x plus tan inverse y. That formula you can use and you can get the answer. That is tan inverse of some value. Now further convert this tan inverse into cos inverse using triangle method. Okay, because the RHS is in terms of cos inverse. So you can convert this into cos inverse using triangle method. Okay. And the ninth problem also you can do it for self-study. Fine. So I'll give the hint for the 10th one as well. LHS is equal to tan inverse of 1 by 5 plus tan inverse of 1 by 7 plus tan inverse of 1 by 3 tan inverse of 1 by 8. So you can group two terms at a time. So this will give you 1 tan inverse plus the other two terms will give you 1 tan inverse. So this is x and this is y. This is x and this is y. Okay. So you'll get the values. Okay. So this will be 1 by 5 plus 1 by 7. 1 minus 1 by 5 into 1 by 7. Okay. And this will be 1 by 3 plus 1 by 8. 1 minus 1 by 3 into 1 by 8. Now this is in turn x and y. Solve again. After simplifying, solve again. You'll get your required answer. Okay. That was question number 10. Let us go to question number 11. Question number 11. Prove 4 times cot inverse 1 by 3 plus cosec inverse root 5 is equal to pi. So cot inverse of 3 will modify the proof plus cosec inverse of root 5 is equal to pi by 4. So we'll prove this. LHS cot inverse of 1 by 3 plus cosec inverse of root 5. So cot inverse of 3, not 1 by 3, sorry, is tan inverse of 1 by 3 plus I'll convert this cosec inverse to tan inverse. Now let's see how to do that. I'll take a new page. Let cosec inverse root 5 be A. Therefore sine inverse of 1 by root 5 is also A. Therefore sine A is equal to 1 by root 5. So that is opposite upon hypotenuse. So this is angle A. Opposite is 1. Hypo is root 5. So the adjacent side by Pythagoras theorem, it is 2. Because 1 square plus 2 square, that is 5. Square root of 5 is root 5. That is the hypotenuse. So this will be 2. This is by Pythagoras theorem. So tan A is equal to half opposite upon adjacent. So A is equal to tan inverse half. So I'm converting cosec inverse to tan inverse. So this is tan inverse of half. So now this is x and this is y. So this will give me tan inverse of 1 by 3 plus half 1 minus 1 by 3 into half. So that is tan inverse of 2 plus 3 upon 6 upon 6 minus 1, 5 upon 6. Okay. So this further will give you tan inverse 5 upon 6 upon 5 upon 6. So this is tan inverse 1. Tan inverse 1 is 45 degrees, which is equal to pi by 4. So that is 45 into pi by 180. Conversion of degree into radian, which is pi by 4, which is equal to your new RHS, right? See, RHS is pi by 4. Okay. Then let us proceed with the question number 12. Just a second. So I think that's it. We'll continue with the rest of the exercise in the next session. Thank you.